All right, folks. So today we're going to talk about simultaneous linear equations in 3 and 4 variables. So what is the approach for us and how should we solve it? And what's the easiest way for us to solve it? So let's take a look at the first example here. We have the first one is x plus y plus z is equal to 0. Oh, sorry, 6. Well, whenever I see the circle there, I thought it was 0. X plus 2y plus 3z equal to 10. And then x plus 3y plus 7, that is 16. So here's a little bit knowledge over here. So how many variables we have right now? We have 1, 2, and 3. If we have 3 variables with 3 linear equations or equations, actually, not linear equation because x plus y plus z is not linear equation there, we can solve it as long as it's not repetitive, as long as we can get rid of some of the variables. So the whole methodology over here is that by subtracting or adding each one or multiplying by a certain number to make sure that a coefficient is the same, we can actually get rid of one of the variable. And then we're going to formulate another simultaneous linear equation bundle with 2 variables. We're able to solve it, just like how we did for the 2 variables. So over here, we look at 1 and look at 2. The solution says 2 minus 1. Well, I can also use 1 minus 2. It doesn't matter. But however, we wanted to be dealing with the positive number there, right? So if we're using number 2 minus number 1, so the x minus x is gone. 2y minus y, you only have y. And 3z minus z, you only have 2z. So y plus 2z is equal to 6, 4, sorry. So because you're getting 10 minus the 6 over here, so which gets to 4. The same ideology applies to the second thing as well, right? And then upon that, hey, you see that if I just subtract them together, use number 5 to minus number 4, right? I know the question is actually using number 4 to minus 5, but then again, like I said, I like to use positive numbers rather than negative numbers. So if I'm using 5 minus 4, what I will get is I will get 2 and I will get 2z. Y has been canceled. Then z is 1. I get exact the same number here. Then what I need to do is to substitute z equal to 1 back into these equations, whether this one or that one, right? Either one will work. So for the question, it says that to substitute into the number 4, equation number 4, because, well, the numbers are smaller and it's easier for us to get it. And then y is equal to 2, right? If I know y is equal to 2, z is equal to 1, then it's pretty obvious that x is equal to 3. So that's how we do it. So I'm going to do the first question over here. Okay, so let's take a look. First, x, y, z, 6, x, 2y, 3z, 14, x, 3y, 7z. So for me, all the coefficient, this is 1, this is 2, this is 3, this is 1, this is 3, this is 7, 1, 1, 1. So give me an idea that I need to get rid of x because it's the easiest to get rid of. So let's try this. If I'm using number 2 to minus 1, again, I want to be dealing with the positive number. I'll get y, 2y minus y, 3z minus z, 2z, y, and this one will be 8. Good. All right, so if I use 3 minus 2, okay, again, this will be 14, and this will be 4z, good, and this is y. All right, now I have the 2 equations right here. All I need to do right now is I'm using number 4, number 5 minus number 4. Again, I'm not sure why the equation asks you to do number 4 minus 5, but I like to do it positively, right? If I'm following that, then this is minus 6, this is 3, z is 3. If I substitute it back, y equal to 2, right? I can ignore that, right? And then if I substitute y equal to 2, x is equal to 3 into it, then x is equal to 1. So 1, 2, and 3. Pretty straightforward. So let's try another question right here. Okay, so for this one, all right, same thing. I have z, x, 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 and I have y, 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 1, 2, 3, and this is -1, -3, -7. Definitely, it's easier for me to get rid of x. So first of all, I'm going to use 2 minus 1. Then I get 4 over here. And then if I use 3 minus 2, and I will get 6 over here, right? Same thing over here applies. So now I want to get rid of y. If I'm getting rid of y, I'm using y minus 2z, subtract y plus 4z, then I will get 2z is equal to minus 2, z is equal to -1. So if that's the case, y plus 2 is equal to 4, so y is equal to 2. And then if I substitute z equal to -1, y is equal to 2 back into x plus y minus z equal to 6. All right, it's not hard to say that. I have x plus 2 plus 1 equal to 6, x equal to 3, right? So then 3, 2, negative 1. All right, good. For the next example over here, what we're trying to do over here, well, nothing too different. The only thing is that right now this is positive z, negative z, and then positive z. So instead of subtracting, what I think that we should be doing is adding them together, because add a positive and negative number, when they add together, that will be canceled to 0, right? So that's the whole point over here. Other than that, everything else is the same. All right. So let's try to do this page. And the hint already is there. So with z eliminated, if I want to get rid of z, first I'll use 1 plus 2, right? Second, I will use 2 plus 3. You're basically creating two linear equations. In this case, is two new linear equations, so that I can just deal with x and y. So if I use 1 plus 2, I will get 2x plus 3y equal to 7. All right, second equation I get is 4x plus y equal to 19. And then I have these two. Quick question over here. Before, I'm dealing with exactly the same coefficient. Right now, I just basically have to do something, right? So I name this as 4 and this is 5. All I need to do is, because, hey, this one is 2, this one is 4, and this one is 3, and this one is 1. So what should I do? Should I get rid of x, or should I get rid of y? The answer is you can do both. You can multiply 5, well, equation number 5 by 3, and then subtract them. Or you can just multiply equation number 4 by 2 and then subtract them. Same way. So let's go with the first way. If I'm doing that, then I will get 4 times 2, right? Subtract 5. In this case, I will have 4x plus 6y minus 4x minus y. Remember to change the sign here, is equal to negative 12. Oh, sorry. In this case, it's not negative 12 because I multiplied 2 already. So negative 5, right? I could actually use 5 subtract 4 equation number 4 times 2. I'm just following the examples. Anyway, so cancel that. I'm dealing with 5y equal to negative 5. Y is equal to negative 1. Substitute this, right? Back into this or that. I can do both. I'm definitely going with that, because, well, number is easier. 2x minus 3 is equal to 7. X is equal to 5. So then I substitute x and y back into x plus y plus z is equal to 2. So all I need to do here is 5 minus 1 plus z is equal to 2. 4 plus z equal to 2. Then z is equal to negative 2. So negative 2 here, 5, and then negative 1. All right. Okay, so for the next question, same thing over here. We're getting y eliminated. And over here, if we're just looking at that, it seems like it's easier for me to get rid of z, right? And let's go to 94. So over here, the question over here is that when we look at all the coefficient, 3, 4, 5, 2, 1, 1, 2 minus 1, 1, and then 1, 3, 2. All right. Definitely going with the least. You definitely want to go with the least and the easiest to solve. In this case, you want to get rid of y. The reason why, hey, if I get rid of minus 2y, I just need to multiply 2, right? I need equation number 2 to multiply by 2. If I want to get rid of that, I just add them together, 2 and 3 together. So that's the easiest way for me to do it. And that's exactly what the equation wants you to do anyway, right? So this is how you solve it. And the other way is, anything else remains the same. The only thing is you have to change the coefficient by multiply the whole equation by a certain number. Okay, we're going to do this question together, so don't you worry, all right? So for this one, we have equation 1, 2, 3. Again, analyzing the coefficient 1, 1 minus 2. 2 minus 3, 1. Plus 3 plus 4, 2. Okay, what do I want to do? I definitely want to eliminate x, right? Well, it's the hint is already here. So if I'm getting x eliminated, first of all, for equation number 1 and 2, do I have to do anything? That doesn't really seem like that. I can use equation number 2, subtract equation number 1, which will get canceled out that negative 5y plus z equal to 15. Okay, that's my first equation. Second equation, however, is equation number 2 and 3. How do I do so? So a lot of you guys ask, hey, Tony, can I use equation number 3 with equation number 1? If I multiply equation number 1 by 2 and then do that? Absolutely. But the thing over here is that, well, I just want to go with the larger number over there, right? So 2 times, well, by the way, by mentioning larger number, because I see this is a larger number here, right? I wanna use that, but I could use the 12. I can use that. I can use 27. Doesn't matter. So equation number 2, I will use equation number 2 to multiply by 2, right? And then I basically add equation number 3. That's all I need to do here. Okay. So I'm dealing with 2x minus 6y plus 8z equal to 54. And I'm basically adding negative 2x, positive y, positive 2z equal to 6. Hey, this is 60. So if I'm doing that, 10z minus 5y, this is canceled, plus it's 60. So that's my equation number 4. Equation number 5. I call this equation number 4, and I call this equation number 5. All I need to do right now is to add or actually subtract, because negative 5 and negative 5, I want to get rid of y at this time. So right now, if I do 5 subtract 4, right, the larger number subtract the smaller number, right here, y is canceled. So I only have 10z minus z, 9z is equal to 45. Z is equal to 5. Done. So z is equal to 5. I can put it here now. And then I substitute z back into the equation. I can do anything. I can do over there. So I can go back to equation number 4. So minus 5y plus 5 is equal to 15. Minus 5y is equal to 10. Y is equal to negative 2. Negative 2. So now I substitute this back into the first one, which is x minus 4. Where do I get the minus 4? Is negative 2 times 2, because y is negative 2, right? Plus 15 equal to 12, right? So x plus 11 is equal to 12. X is equal to 1. So done. So this is how we do this question. All right, page number 95. So let's look at this as well. Right, the whole notion over here is that instead of just multiply one of the equation with a certain number, like the previous one, we're only multiplying number 1 by number 2 by 2, right? And to get rid of that, this case, we are trying to find out the common multiplier, or actually the LCM, my bad. We're trying to find the LCM and multiply the difference. Giving you a sense here. When dealing with this question here, what I want to do is 6x, 5x, 2x. What is the LCM for 6, 5, and 2? In this case, should be 30, right? So how should I do that? Well, first of all, how do we find LCM? 6, 5, 2. 2, 3, 5, 1. I call this the both method. Anything else? No. 1 times 5 times 3 times 2 is 30, right? That's 30. So if I multiply this whole thing by 5, or if I multiply this whole thing by 6, or if I multiply this whole thing by 15, I will get 30. So it's going to be easy for me to eliminate. However, in this case, we're not doing that. We're not multiplying number 3 by 15. That's going to be too complicated. All I need to do is actually, if I'm eliminating x with equation number 1 and 2, I just multiply each one by 5 and 6 correspondingly. if I'm eliminating x with equation number 1 and 3, I'm just multiplying equation number 3 by 3, right? I will get the same coefficient as 6. So that's how I do it. So I'm not going to go in too deep for this equation. I want you guys to try it yourself. So I'm going to leave this question hanging over there. So if you guys have any questions, please let me know. So the rest of the questions, it's very similar, right? You're basically just using different methods. However, I do want you guys, just for the sake of it, to try this one here, number 100 here. Evaluate it, analyze it, and see which method, which direction do you want to go? Or in another way, right? Which variable do you want to eliminate? Is it X? Is it Y? Is it Z? Trust me, always go with the easiest coefficient, because that's going to benefit you, and less calculation anyway. So solving simultaneous linear equation is like all roads to Rome. It's kind of like the same notion over here, is that you can use a lot of methods. You can eliminate any variables if you like of your choice, but we always want to go with the optimum one, right? The less steps, less calculation is definitely better. The lazy method it is, okay? So that concludes today's class. Let me know, comment below if you guys have any question, and I can talk about it.